library called Pandas. It is a data analysis library. And the objective of this video is to just give you a short introduction, show you what you can do with it, and then I'll finish off with an example of how we can answer a data analysis question using this library. So I've divided the video into a few sections here. So first of all, we'll be loading the data, then we'll explore the data. Like if you open up some data in like a spreadsheet in Excel or something, it's very easy to get a visual overview, but you got to know the methods when working in Pandas. So I'm going to show you how to do it. It's very simple. Then I'm going to show you how you save the data, and lastly how you can use all your new skills to analyze some data. So prerequisites are nothing really, but I wrote down that Python experience will help you because it is a Python library, and everything you know in Python you can apply to this library as well. I've always worked with data in Excel, so this is very new to me, but I already like it much more because it's very flexible. I already use Python for a lot of things, so that obviously helps. That again, anything I can do in Python, I can do in Pandas. So it's very easy for me if there's something specific I want to do that I know from Python, I can just throw it in here. I've noticed that it is able to handle way more data than, like for example, Excel, because you don't rely on this graphical interface where you constantly have to see every row of the data you're working with. So that's better here. I also really like how this is specific to, well, it's not specific to the notebook I'm in here, Jupyter, but generally you can see the steps that you have taken to come to a conclusion. This would work in pure Python as well. We're gonna see that by the end of this video, how this document turns into a data analysis document, and it's very easy to, if someone goes in and check out the document, what I have done to come to the result. And if you want to modify something, it's very easy to jump in and just do it. Obviously there are some cons here, or there's a single con I could list, that it has a learning curve. Depending on your background, if you've done Python before, it'll be super easy to jump into. You kind of know what to expect from a library. If you haven't done that before, maybe it'll be a bit different to you, but I'll cover the basic things you can do here, and it should be easy to just jump into, and once you know what you can do with it. So the tools we'll be using here are obviously Python, because it's a Python library. I'm not going to go too much into Python, but it's a language that I really enjoy working in because it has a very light syntax, and it has these a lot of awesome built-in methods in the language itself that I can use to manipulate data. I can do very strong things in just a couple of lines. And specifically when working with data, it has a lot of libraries and a huge community. So yeah, it just has very good support for those libraries. I am running Python inside of this notebook here. It's called Jupyter Notebook. And the reason we use it is that we can create both, I can, like, this is Markdown I've written in here, so I can have notes and I can have my Python code like in between, and it's just a very good way to share your results when working with data. We'll see it in action. Just want to tell you that that's what I'm using. And then we obviously use this library Pandas, which is a Python library, and you use it to work with data. You can load data from a lot of sources. I've written CSV Excel here, but you can actually read from a lot of other sources. Like if you have an online JSON endpoint, XML, SQL databases, you can just read it and it'll save a local copy for you, so you can work with it. Otherwise you use it to plot data. Actually, I believe it uses another library behind the scenes, but you don't have to worry about it because it just makes it so easy for you. And then you can use it just like you would in a other spreadsheet applications. You can filter, sort, and modify your data. So what you want to do when you install it is, if you never used Python or anything similar before, you probably just want to install this package called Anaconda, which comes with everything pre-installed for you. So it'll have Jupyter Notebook, it'll have Python, it'll have Pandas. You don't have to worry about it. It'll have a bunch of more stuff for working with data analysis. But you can also just install it manually. So what you want to do there is get Python up and running on your system. You might have it already because it comes pre-installed in many operating systems nowadays. Otherwise, you just go here and download the latest version. And then from Python, you want to use, is there a package manager called pip to easily install Jupyter and Pandas. All right, well, let's get going with the example here that I prepared. So first thing you want to do is import it so we can actually use it, the library Pandas. And what we do in Python syntax here is that we import it, and I've just given it an alias. So instead of having to write Pandas every time, you can use a shorthand called PD. When you work in Jupyter, you have these cells. So this one hasn't run yet. What I do is I'll hit Shift Enter and it'll run the cell and jump to the next one. So now I know that this is the first cell to be run. That means that now whatever I run up there, I can bring to the next cell. So you can see here, if I do PD dot and then hit tab, it'll suggest a lot of methods that comes in the Panda library. One of them, which is read, and you can see all the different data formats that it can read here. And this is what we're doing down below here. So we're making a new variable called df, short for data frame. Data frame is like the main object that you're working with in the Pandas library. So this is what you read your data into, and then you get access to a bunch of different methods to show or modify your data. So what we do here is we read a CSV file. It's something I have lying around locally here. I grabbed it from this open data site here called kaggle.com, and I put it here. So if I just list the content of the folder I'm in, I can see that I have this file here, Raymond Ratings. Let's just try and print it out. Raymond Ratings. And you see I have a standard CSV file. We can't actually see it here because there's so much content. So let's open it up in a spreadsheet editor. So we have the review number. So it's just like the index basically. We have a brand. So who produces these, Raymond? We have a variety, which is a special column here because they are very specific, these varieties. Yeah, we have a style, which is a bit more like categorical. We have cup, pack, tray, and so on. I don't know exactly how many there are. Then there are country, I guess, of the rating. Then we have stars, like the number that whoever made this rating gave the product. Then we have this column top 10. I actually don't believe it does anything, so I could just delete it. Delete the column. See if oh, then it wants me to. Never mind, we'll just keep it. Going back, so this is the file we are reading in here, and what we're doing down here is we're just putting the variable, and what Jupyter will do then is try to print it out. If we just leave something at the bottom here, it'll try to print it out. It's similar to like if I say 2 plus 2. If you're just running Python and wouldn't do anything, you would have to specifically print it out like this. But since we're in Jupyter, it'll try to print it out. And here's this 4. Same thing happens, just delete this, with this data frame. So if I run this, it'll print out and give us a small preview here. So already you see it's much more light than working in a spreadsheet application because it'll just give us a top 5 and bottom 5 rows. So we get kind of an idea of the columns and what's the content of each. So there are actually 2,500 rows, but we wouldn't really be able to tell all the content just by scrolling up and down anyway. So this is a fine preview just to begin with. But if you want to take a closer look, like this is what I call exploring data. There are a lot of methods we can use to do this. We've already seen the columns here, but just show you quickly that you can actually access them by calling the data frame.column, so you'll get them all here. I believe this is like if you know Python, this is like a list in Python, so I can actually go and find one based on its index. In Python, we start with index 0, so if I want to grab this one, I could say index 0, print it out. Yep. We'll just leave this for now. You can look at the types of data here. So for each column, it'll say which type of data it contains. So the first one is an integer. You see here, review, that makes sense. From 1 to 2,500 something, 80. Rest of these are objects, and I believe this is just how pandas interpret this. It's basically text or strings, however you want to call them. And stars here, that's a floating number because it has these like 3.75. These are very useful for quickly checking your data, because I often run into an error where, like, if one of them doesn't have a rating, actually this one didn't, I have to go in and clean it up. It'll say like either empty or unrated or something like that, and then it'll not know what to do about it, and will probably just convert it into an object. So this is useful for later when we want to get the average rating, for example. We need to have it as a float. It can't calculate the average based on if it is an object, something like that. So we're already going to look at that here. There's a method called describe, which just gives you an overview of, I believe, all the numeric columns. So review isn't that interesting because it's just incremental from 1 to whatever the count is. But the stars, we can get here the mean, like the average rating, which is 3.6. We can get the standard deviation, minimum, all of these percentage quartiles, the max. So we can see that there is actually a rating of 0 and there is a rating of 5. If we want to just look at a single column for some reason, what we do is take our data frame, put these square brackets, and put the index of the column. So that's stars here in our case. And we'll get a new data frame where it just has a single column. Instead of passing it this string called stars, we can pass it in a list as well with multiple strings. So this way we'll look at multiple columns. We can also filter. So the way we do this is, like, if you want to select a column, you just directly put these square brackets. If you want to select some rows, you put this .loc. I haven't been able to figure out what loc actually stands for. Some says location, but I'm not really sure. But anyways, it's how you access rows. So if I want to get the rows where stars, the value of stars here is above 4.5, this is how I do it. So you can see here that no star go below 4.5, and I only get 450 results. I could also have multiple conditions, and the way I do that is similar to before, but when I have multiple, I need to put parentheses around my condition and then have an ampersand and then the next condition. This is a bit weird syntax. It's Pandas specific. This is not how you do it in Python, but it's just, this is how Pandas choose to do it. I don't really like it. It's just something you have to remember. But anyway, you can put a second condition over here. So we're saying that rating should be above 4.5, and we only want to see those from Japan. So this way, we are now down to 97 rows. Here I have an example where I actually face a problem. So I want to look at the varieties and I want to get the ones where it has chicken in it. So I only get 7 7 of these ratings, you could call them 7 rows. Or 1, 2, 3, 4, 5, 6, yeah, 7. I don't know why it doesn't display to me here how many rows there are when it does for the other ones. Someone knows that, please comment it to me. But anyways, the problem is that it only matches the ones where it says exactly chicken like this, even with the uppercase C. And I believe that we could find many other cases, like if it would say curry chicken, for example, then it wouldn't appear here. So what we can do is use a little of, here I use some Python knowledge. I don't know, maybe there is a Pandas method for this as well, but I'm gonna say that I want the rows where variety. We want to get the string of that, and we want to do it in lowercase. This is just, you are familiar with this if you know programming, but you don't want to match only the ones where it has this uppercase chicken, so we just convert it all to lowercase, both the value and what we compare it with. And then we get 328 results only. So you see here that we have something called special chicken, kung fu chicken flavor, etc. And we want to include all these when we're just looking at the ones with chicken, depending on exactly what we want to achieve, of course. But like, then you would have to do something like that. Okay, so on to plotting. So as I said, it's very simple because it has this built-in plot method, but you could also use an external library for this if you want to go for something advanced. So here I am, let me just back up actually and show how, if I take data frame, there's this plot object in it, and if you press dot and then tab, it'll try to suggest you the different methods that it has. And you can see all the types of plots here. You would always just refer to their website, but here you can easily get an overview of what you are able to do. So down here I have an example of plotting in histogram, where I put the y-axis as the stars column, and that looks like this. It's very easy to make a simple plot like this, and this way we can see that where most of the ratings, like the value of the ratings, where they are here around 3.5, 4. If I don't put an argument of y, it'll just try to guess for me, and it'll put, so in this case I guess it's everything that's numeric tries to plot, but we are not really interested in that, so we just go for this one. Okay, another thing you can do here is you can sort your data set. So what I'm doing here is trying to sort by the highest rating and then just show the top 5. So we take data frame, we sort values, it's called, and we have to provide here a column name that we want to sort by. So we sort by the stars, and then I've given it an argument ascending of false. That's because by default it sorts by ascending, which means that it'll start with 0 and go all the way up to 5 in our case. And I want to look at the top 5. So here we get sorted by stars, the top 5. What I could do instead, just want to show you here, that if I sort by stars, like I said, it'll go ascending, so it'll start with the lowest ones. But I could just instead select the last ones in the data frame here. And how I would do that is, instead of calling head, I would call tail, and then let's see the 5 bottom ones, and I get the same result basically. Just in, I could say that it's sorted in a different order. Right. Another thing I can do is look at a single column. So I want to see here how many of each value are there in the column style. So how many ball, how many pack, how many cup, etc. So I do that by grouping them. So it'll take a look at the column style, and then like every time it finds, say, bowl, it'll put those together. And I can't really plot or print that out, but I can call some methods on it. So for example, I can call size here, and we'll just get the count of each. Another thing I can do, there are more methods like this, called the mean. like so it'll group them, find all of the, for example, the pack, well, the ones where pack is the style here, and it'll find the average for each numeric column. I'll just revert this back to the size because we're going to use that for an example here. So we're going to do exactly the same thing, and then we're just going to plot it out in a bar chart to get a more visual overview. And there we go. So next thing, and this is going to be a short one, but just want to show you how you can save your data. So if you do something and you want to get it out of this, this document here, you can, for example, take your data frame, and as I do here, select the top 5 ones, and you can save it to a CSV file. I believe you can save it to lots of different things here. And you just give it a name. So if I run this and go and check, it's just the folder I'm in, now has this first 5 rows of the CSV, and we can look at that. Here we go. Or we could open it up in a spreadsheet if that's easier for us to read, and see that we have selected the top 5 rows and saved them in a new file. So selecting 5 rows is a very simple example, but you can do all sorts of things. As long as you have this, you still have this data frame object, you can save it as any type of file. Let's just look at here for fun and see 2. So yeah, it'll have a lot of different formats. Same thing you can do with a plot. It just has this ugly syntax that I can never remember. What you do is basically just you do a normal plot like this, and then you add .getFigure, and then you save the figure and give it a name. So it'll actually show you the plot, and then if you look at the folder here, it made a PNG file for us. So if we open up that one, we have exactly the same plot, just exported in a file here. Okay. So now we actually want to use this, all the knowledge we just gained, to answer a question about this data. So the question I prepared is, which style of ramen scores the highest? So the first thing we're doing down here is, actually we will assign this to a new variable, just to make it more easy to work with it later on. But I'm gonna assign it to our regular data frame, group by style, getting the mean as we saw before, and then sorting it by stars and selecting the column stars. So that's a lot of things. Let's just break it down. So what I'm doing here is grouping it by style. Let's try and run it. Prints nothing, but if we get the mean values, you can see here that we have the style as an index and then the mean or average rating for each. Then we sort them, sort values by stars. So we get in ascending order stars here. And then we say that we don't really care about this review column, so we keep just the column stars. And we print it out. So same thing here, just had to break it down. So now that it's saved in a new variable, it's very easy for us to just say this data that plotted into a bar chart. And then we get a visual representation of, in ascending order, the rating for each style. So now that we're analyzing this, we have to think about how valid the data is. And the first thing that comes to mind here is that the bar style scores a perfect 5. And that seems unbelievable. I can't really believe that every single person that had this type, I don't even know what it is, a bar, like, is it served at a bar, or is there actually bar ramen? I'm really curious about that now. But anyways, is it because there aren't a lot of ratings? It's just a single guy who scored it a perfect 5. So we're gonna try to remove some noise here. And the way I want to do that is try to count how many. So here, up here we just have the average rating, but actually count how many ratings there were for each style. And I'm gonna do that by making a new column. We haven't covered this, but the way you do it is you take the data frame here and you create a new, this column doesn't exist. I guess if it existed, it would just overwrite it. But we assign that to be the original data frame grouped by style and then taking the size, just so we did before, where we can see how many there are for each. Just to clear this up, show you, up here we print our style. We say we want a new column, call it count, and we want the number of ratings for each. So we get those by doing like this. And this might seem a little magic, but I guess the way it works is that it has an index called pack. So it's able to match up here, the index called pack, and then put in the actual value over here. Anyway, when we do this, I'll just delete this. So at the bottom, we just print it out in a sorted form. We get this, exactly what we wanted. So, as we suspected, the one with the perfect score only has a single rating, so we can't really use that for anything. So let's just try and make a new plot where we only display the ones that have at least 50 ratings. And we do that by, so this is our data set now. We select the rows where the count column is at least 50, and then we just plot it like we did before. And there we go. So what we can see here is that the style that scores the highest is the pack style, and the style that scores the lowest is the cup style. It's very close, but you are able to see the difference here. And that is basically it. I don't have anything else here, but I hope you enjoyed this short introduction. As I said, I recently got into Pandas, and I really enjoy this way of working with data. Like it's very different from Excel, but yet you still accomplish the same things. It's just very flexible, especially if you're familiar with the language Python. But anyways, I hope you enjoyed it.